Last time we had left off at the very end of section 14.1. We've been talking about linear measure, and the point where we are is talking about the circumference or portions of the circumference of a circle. And I think this is our slide that we're on. Does that look right to you guys? Excellent. Excellent. Okay. So we were on number 2. It says if a circle has a circumference of 0.68 meters, what is its radius? And last time before we had left, we had written down the formula that we were going to need to use, at least sort of the more natural formula, which is the circumference equals 2 pi r. How am I going to find out the radius when I am given the circumference? Okay, so the 0.68 is the circumference, and 2 pi r is what is equal to that. And then how would I find out what r is? Yeah. I'd like for you to grab your calculator because I want to make sure that we're all comfortable with how this division works so that the calculator doesn't misinterpret what we mean. Because there's a very easy mistake to make if you're not careful here, and we want to be careful. So as you put this into your calculator, somebody tell me what answer your calculator gives you.
0.108225.
Okay. And I think that's the right value, Elena. Does anybody's calculator tell them something differently? Nobody's did? This is in meters, right, guys? Okay. Any guess as to what students might have happen if they aren't careful, what the error might be?
It might multiply, like, it might divide first and then multiply the whole thing by pi.
Right. Some of your calculators, so if you have a graphing calculator, like the TI-83s, TI-84 kind of ones, and some of the scientific ones do this too, but if you just put this in like this, your calculator will in fact do exactly what Amy said. It will divide by 2, and then it will multiply by pi. But of course, pi is supposed to be in the denominator. So any idea about how you make sure that your calculator doesn't do that? Yeah, put the 2 pi in parentheses. So if you don't have your calculator with you, so you don't know if yours does this, just be careful and be aware that that is a possibility. And this should sort of make sense. Pi is about 3.14. And if you double that, you're going to get about 6.28. So if you're dividing 6.68 by 6.28, that ratio should be about 1/10. And that's what you're getting in this answer. So if you aren't getting an answer that was 1/10, that would be concerning. All right, number 3. What is the radius? I didn't see that right. What is the length of a semicircular arc of a circle whose radius is 1/2 inch? Okay, so this is not the whole circle. How much of the circle is it? It's 1/2. Now, you could actually use the circumference formula, which is 2 pi r, and just use half of it, which would be, don't overthink this, pi r, thank you. Yes, half of 2 pi r is pi r, right? Yes, it is, okay? So you could use that. The other thing that you could use, and I'm going to use this one just because we have a formula for it, and it works even if it weren't a semicircular arc, is that last time in class we had given this formula for length. The length is pi r theta over 180. So this theta will work no matter, this length formula will work no matter what theta is. In our situation, we're dealing with a semicircle, so what's the theta? It is 180, right? So if I had a circle, I don't have very much space on the slide, but if I had a semicircle across here in the middle, the angle right here of the central arc, theta, would be 180. So this formula would work no matter what, so let's go ahead and use it just for the sake of practicing a little bit with it. So we have a pi. Our radius was actually 1/2. Theta is 180, and we're dividing by 180. So the multiplication factor and the division factor of the 180, those cancel. And all I'm left with is pi over 2. This is pi over 2 inches. And then so that's the exact answer, and then we'll change and give an approximation as well. So we're going to include both of these answers. So if you take pi and you divide by 2 into 2 decimal places, what do you get? It is 1.57, and again, it's inches. So if we were to measure around the circle here, we would get 1.57 inches long. So think about like the flexible tape measures that you guys used on the wall the other day. That kind of a tape measure would work. Yes, ma'am.
Like for the homework problems, in the back of the book, they leave them as fractions. Like, for example, the one before would have, it would just leave it like that. Do you want us to write decimals instead?
On which ones?
Like, just some of the homework problems in the book,
Mm-hmm.
like, they'll leave them as like 3 over pi or something like that. Do you want
Um,
us to write decimals?
That's a good question. So I like the fact that the exact answer gives us an exact representation, and that's important in mathematics to keep things as exact as you can. However, if you were practically speaking and you were working with a word problem, especially with word problems like that have actual context, these are sort of not like that, the ones that are on the board right now, right? They don't really have any context. But if you were really measuring a CD, you know, the edge of, or a DVD, if you're actually measuring around a tire and you told somebody the answer in terms of pi, they would look at you like you're a little crazy, right? So yeah, I'd like to see the answer also with decimal representation, simply because, especially with ones where there's context, right? Again, these we could sort of say maybe don't really have context, they're just giving you the nuts and bolts kind of things. But especially with ones with context, it makes a lot more sense to have decimal representation included as well. Does that make sense to everybody? Okay. All right.
Sorry, I have one more
Yes.
question. Why would the formula 1/2 C, standing for circumference, equals 2 pi times 1/2?
It wouldn't equal 2 pi times, it would equal 2 pi r divided by 2. And then the 2's would cancel, so it would be the same thing as pi r. And in this case, r was 1/2, so there's the pi r that you're coming across. Pi times the radius r. Yeah. Yeah. Okay, last one. What is the radius of an arc whose central angle is 82 degrees and whose arc length is 160? So this is the same formula that we used before. Whoops. Well, I'll use the pink. I'm already in there. Which had pi r theta over 180. But the information they give us is a little different than the last one. What information are we actually given? We're given the length L, right? What is the length L in this problem? 160 centimeters. Pi is a number all by itself. R, radius, that's actually what we're looking for, right? And then the theta is the other piece they give us as 82 degrees. So you have 82 degrees over 180 degrees. All right, so what are we going to have to do to solve this problem?
We're gonna have to isolate R.
Yes, we need to get r by itself. So what am I going to do first to do that?
Multiply the right side by 180 and multiply the left side by 180.
Okay, so we're going to multiply by 180. Excuse me. Actually, let me do it like this. On both sides. So what is 160 times 180?
3,100.
And actually, we could have just canceled the degrees out here and not worried about it because they will cancel. That's kind of the way it's going to happen, so I'll use it like that. What's next? Divide by what?
82 pi.
Yeah, 82 pi. All right, and that will isolate r. So what is 28,800 divided by 82 pi?
111.79.
What comes after the 9?
656.
Yeah, so it'd actually be 80, right? With 2 decimals. And our units on this one were centimeters, yeah? So this is one of those ones where, I mean, yeah, we can, the exact answer is the 28,800 over 82 pi, and we could reduce that a little bit because they're both even. But that answer doesn't even hardly make sense in terms of finding a value for a radius, right? So this one's radius is approximately, I should have put approximation too. This is approximately 111.80 centimeters. It was 111.80. 0.796, like that. And so then the 6 at the end will round the 79 up to an 80. All right, any questions on that one? All right.